All right, welcome back. So we have a character. We have a/character, and it's based on the character class. Now we're ready to add some inputs to this character. So we're going to compile here and launch the editor, and we're opened back up to this default map here. And what I'd like to do first thing is create a blueprint based on our new character class. So here in C++ class is /public. We have characters now. Here's our /character, and we're going to make a blueprint based on this. So we'll go back to our blueprints folder and make a new folder in here called characters. And in this characters folder, we'll make our blueprint based on our /character. So let's make a new blueprint, and under all classes, we're going to search for /character and choose that and click select. And we're going to call this BP_/character. Now we have a character blueprint based on our C++ class. Let's go ahead and double click that to open it. And right away, you're probably noticing something the other actor blueprints did not come with by default. We have a capsule, and we also have this blue arrow, which is an arrow component. Now this arrow component simply exists to show us which direction is forward, and we see that it's pointing in the x-axis direction, which we would expect. And we have experience with capsule components, but I'd like to point something out to you. Notice that our character's root component is the capsule. If we hover over it, it says this is the default scene root component. And it says it cannot be copied, renamed, or deleted. It has been inherited from the parent class, so its properties cannot be edited here. That just means that this is a C++ variable exposed to blueprints. So a C++ variable exposed to blueprints cannot be deleted from the blueprint. We've coded it into the C++. So that's something that C++ programmers have power over that people editing in blueprints do not. Now it says new scene components will be automatically attached to it. So we have all the other components attached to it, except for, of course, the character movement component, which does not need to be attached to anything, as it doesn't have a mesh, it doesn't have a visual representation, kind of like the controller, it's invisible. And if we click on this, we'll see that it has some similarities to the floating pawn movement component, which we added to our bird pawn, only it has more capabilities because it's designed for characters, specifically humanoid characters. It has a gravity scale. By default, characters have gravity applied to them. It has a max acceleration, a braking friction factor. These are all factors that we can use to determine the behavior of movement for a given character. Now, we haven't programmed any movement functionality for our character just yet, but we will. And we have the arrow component attached to the capsule. Now, notice here we also have something called mesh. It's a skeletal mesh component called mesh, and this is inherited from the character class. So the character class already has a skeletal mesh, and it's attached to the root being the capsule, of course. So we don't need to create a new mesh variable in our character, as it already has a mesh inherited from the character class. And this mesh, being a skeletal mesh component, has a skeletal mesh variable which we can set by clicking the dropdown. And for this, I'm using echo for my skeletal mesh, so I'm going to select echo. And all of a sudden, I see echo here, and right off the bat, it doesn't look quite right because it's raised up and facing the wrong direction. But that's okay because we can rotate this to face the correct direction by hitting the rotation icon and rotating by 90 degrees. So by doing that, it's now facing the X direction of the character blueprint, so now it's at least oriented correctly. And we can also move it down. So we can choose translation mode, and we can move this mesh down in the Z direction so that it's all the way down here at the ground. And we may want to turn off snapping to get it just right. So now our capsule looks like it's pretty much surrounding the character, and it looks pretty good. So this is our character. We can compile and save it. I'm going to dock this up here at the top. And if we drag our character in, so here's BP/character, we can drag this right on in, and here it is. It's right here, and that's what it looks like. So it's pretty static. There are no animations. If we wanted to, we could apply an animation to it. We know how to do that. We can just select the mesh and look for the animation section and choose Use Animation Asset. And if we did that, we could choose any of the animations provided in the character folder for us, such as if we search for idle, there's an idle animation. And now our character is idling. So that's pretty cool. And the cool thing about Echo is the idle animation has the eyes moving and blinking, and there's a lot of detail there. So that looks really great. And if we look in the world, if we go ahead and press play, well, we know that we're possessing the bird pawn, but we can go up close and see that character idling, blinking the eyes, and things like that. So it looks really good. And we can also see that the feet are above the ground a little bit. We might want to move her down a little bit, so we can do that as well as we're fine-tuning. So I can sort of move that down a bit and press play and see how that looks. I think that looks a lot better. Okay, so we need some movement. Now here's the cool thing. If we go to Edit and Project Settings, we can scroll down and click on Input, and we have these input axis mappings. We have Move Forward, we have Turn, we have Look Up. And we can use these in our character as well. So we'd like to be able to move forward, right? So let's make a function for moving forward. So we'll head back into our Visual Studio project with /character open. And I'm not really using bird or item at this point. I can go ahead and close those tabs out and just have /character. And we can make some functions to bind to our axis mappings. And we'll start with our move forward function. So let's make a protected section for these. And we'll first make a void function called move forward, which takes a float called value. So we can go ahead and define the move forward function. Let's do that. And here we have it. And we'd like to bind this to the move forward axis mapping. And we can do that in Setup Player Input component. So let's go ahead and bind the move forward function. So to do that, we take our player input component, input parameter, and call bind axis on it. And we need the name of the axis mapping. We're going to use an fname and pass in move forward. Next is the user object, and this time it's this particular character, and we can always get a pointer to this character by using this. And finally, we need the address of operator followed by the fully qualified name of the function, which is a/character move forward. So we're going to put that right there. And now we have our move forward function bound to the move forward axis mapping. And we can program some movement functionality here. Now, if we'd like to move the character forward according to its forward vector, we can do that. If we take a look at our bird class here in bird.cpp, we can see exactly how to do that. We check to make sure that this character is possessed by a controller, and if the value is not 0, we get the actor's forward vector and call add movement input. So we can just quickly get this working if we copy this code and paste it right here in move forward. And notice we can call add movement input in a character class as well, as this function is inherited since it existed in the pawn class. And add movement input checks to see if we have a movement component and moves the character. Now let's save all and go back into the editor. And what I'd like to do, just to make this easy for us to test out, is to change the default pawn in our game mode. So I'm going to go ahead and remove the bird pawn. I'm going to remove this character and simply go into our blueprints folder, open game mode, and BP bird game mode. Now, I don't need to open the full blueprint editor as I can see all the details here. And all I need to do is take that default pawn class and change it to BP/character and compile, save, and close out of bird game mode. And now we can choose to use that game mode here in this minimal default level. So right here in the world settings under game mode, we can choose game mode override and select BP Bird Game Mode. So I'd like to go ahead and compile from here in Visual Studio. So I've closed out of the editor. I'm going to Control F5 and compile and launch. So now we can press play. We're possessing the character, but we can't really see it. But we can click and move forward and backward. That much is working. But if we hit Shift F1 and detach with this icon here, we can turn around and actually see the character. We just can't see it when we're sort of attached to it as we're inside the character. And we can't see from the inside out, at least not very well. So that's because we need a camera and spring arm, right? So we can look down on the character and see what it's doing. But we know that moving forward and backward is working. We can do that. We can't move side to side, so we're going to have to take care of that as well. But at least this much is working. So we're going to hit Shift Escape. And in the next video, we're going to add the camera and the spring arm so at least we can see what we're controlling. And then we can start adding more movement functionality so the character can start running around and becoming more dynamic. So excellent job, and I'll see you in the next lecture.